into one, the ideal gas law. Well, what are the three laws? The first law is Boyle's law. What does Boyle's law say? Pressure multiplied by volume will remain a constant when the temperature is a constant. What does the pressure law say? Pressure divided by the Kelvin temperature remains a constant when the volume is a constant. What does Charles' law say? Volume divided by the Kelvin temperature will remain a constant when the pressure is a constant. So these are the three laws. PV equal to CT. We can combine all those three together and write it like this. PV equal to CT. Now look at that, those three laws one more time. We get PV equal to a constant when T is a constant. P over T is a constant when V is a constant. And V over T is a constant when P is a constant. Does it make sense, therefore, to combine all these things and say, therefore, PV divided by T, is that right? I can say PV divided by T will remain an absolute constant. This is the combination of all these three, and that gives me PV equal to a constant multiplied by T. PV equal to CT. That is a combination of all the three laws. And now, what does C stands for here? C is a constant, and what does its value depend on? It depends on the amount of gas that you have taken for your study. So C here is a constant which depends on, whose value depends on the amount of gas you have taken. And I'm going to write the C as C equal to K times N, where N is the total number of molecules of the gas and K is a constant. N is the number of molecules of the gas and K is a constant called Boltzmann constant. You see? So this constant to C, I want you to pay special attention here. This constant to C is Boltzmann constant multiplied by the number of molecules of the gas. That gives us PV equal to K times NT. K is Boltzmann constant. I will give you its value as we go on. N is the total number of molecules that you have taken in your sample for study. The value of K is determined as K equal to 1.381 times 10 to the negative 23 joules per Kelvin. That is the value of Boltzmann constant. Alright, so we have PV equal to K and T. Now, do you know what Avogadro's principle says? If you have done a little chemistry, you would know that. According to Avogadro's principle, 1 mole of any substance under the same conditions of temperature and pressure contains the same number of molecules. 1 mole, that's the unit of measure, a basic unit of measure in chemistry or in any substance. 1 mole of a substance under the same conditions of temperature and pressure will contain the same number of molecules. If I take 1 mole of hydrogen, it will have the same number of molecules as 1 mole of oxygen under the same conditions of temperature and pressure. That number is called the Avogadro's number. This number is called Avogadro's number and is represented by Na, Avogadro's number. What does Avogadro's number give you? The number of molecules in a mole of a given amount of substance. Now, therefore, And this has a value, Avogadro's number is 6.03 times 10 to the 23. Any 1 mole of any substance will contain 6.03 times 10 to the power of 23 molecules under the same conditions of temperature and pressure. When you vary the conditions of temperature and pressure, it will change. And therefore, is it possible to write this N? What does the N stand for? N stands for the total number of molecules in your sample. Now, therefore, that N can then be written as N equal to small n times Na, where small n is the number of moles of gas that you have taken for your study. So, if you have taken a certain amount of gas inside this container, the number of moles of gas multiplied by the number of molecules per mole. You see, Na is the number of molecules per mole. So, number of moles multiplied by the number of molecules per mole will give you the total number of molecules in your sample. So we will now write N equal to, this N we are going to write as small n times Na, where small n is the number of moles of gas and Na is the number of molecules per mole. And that gives us PV equal to NKNAT. Alright, what are these quantities? N is the number of moles, K is the Boltzmann constant, Na is Avogadro's number, and T is the Kelvin temperature. Now, this quantity K times Na, K times Na has got a great significance. K times Na is a great constant. We normally write it as uppercase R, and it's called the universal gas constant. So the universal gas constant R is Boltzmann constant K multiplied by Avogadro's number Na. The product of those two famous constants is called the universal gas constant. So we can now write that relation PV equal to nRT. That is a beautiful equation in chemistry, where N is the number of moles of gas, R is the universal gas constant, which is equal to K times Na. I will want you to recall this relationship many times in the next few lessons. So keep track of this. This is the statement of the ideal gas law. So what does the ideal gas law tell you? Pressure times volume equal to nRT. N is the number of moles, R is the universal gas constant, which is given by K times Na times T. And I'm going to give you a couple of values for R. The values of R will depend on the units in which pressure, volume and temperature are measured. Now in chemistry very often, pressure will be measured in atmospheres and volume will be measured in liters. But in physics very often we measure pressure in Pascal and volume in meter cube. So depending on these units, the value of R will change. Look at this. When pressure is measured in joules, when pressure is measured in Pascal, when pressure is measured in Pascal and the volume is measured in meter cube, the value of R will be 8.314 joules per mole per Kelvin. That is the value of R when pressure is measured in Pascal, that is Newton per meter squared, and volume is measured in cubic meter. Now, when pressure is measured in atmosphere and volume is measured in liters, as very many times chemists do, then the value of R will be this. R equal to 0.08206 liter atmosphere per mole Kelvin. Now, this actually tells you that the volume is measured in liters and the pressure is measured in atmosphere. You can see, if you use absolute units, liter times atmosphere, when you convert that to Pascal, it will become a joule. That's right. Okay, so we will use the value of R, either this or this, depending on the units of pressure and volume. Alright, again, keep track of these values. Let's do an example. A gas is kept at a constant pressure. If its temperature is changed from 50 degrees Celsius to 100 degrees Celsius, by what factor does the volume change? So here, a gas is kept at a constant pressure. Constant pressure. That means we are studying the volume with temperature. What is the law that gives you the relationship between volume and temperature? Well, first of all, our initial temperature is 50 degrees Celsius. And remember, these laws always uses the temperature in Kelvin. So, convert the temperature to Kelvin. 50 degrees Celsius is 273.15. For the purpose of our calculation, we're going to drop that 0.15. We will take 273 plus 50, which is 323 Kelvin. So convert temperature in degrees Celsius to Kelvin by adding 273 to it. T2 is 373. 273 plus 100, 373. So, for a constant pressure, what is the law that we're going to use? V over T is a constant. What does this mean? V over T is a constant. If V1 is the volume when the temperature is T1, and V2 is the volume when the temperature is T2, then V over T is a constant means what? If V1 and T1 are the volume and temperature in state 1, and V2 and T2 are the corresponding quantities in state 2, then V divided by T is a constant, means that V1 over T1 equal to V2 over T2. That's the meaning V over T is a constant. You can take the gas into any number of states. V over T is a constant, means V1 over T1 equal to V2 over T2 equal to V3 over T3, and so on. Alright, so in this case, if V1 over T1 equal to V2 over T2, then V1 divided by V2 will be equal to T1 divided by T2. Well, we are given the values of T1 and T2, therefore we can find the value of V2 over V1. T2 is 373 and T1 is 323, and that is 1.15. V2 over V1 is 1.153, means V2 equal to 1.15 times V1. That's right. So we have answered this question. By what factor does the volume change? V2 over V1 equal to 1.15 means the final volume is 1.15 of the initial volume. Okay, another one.